Okay, good morning, everybody, or good afternoon, or good evening, no matter what time zone you're in. I'd like to welcome you all to the third webinar in the High Weather webinar series. Our webinar today is about user-oriented evaluation of high-impact weather. And if you've been following the webinar series, you might have joined the ones about communication and impacts and vulnerability. And in the next 2 weeks following this one, there are 2 more webinars about hazard forecasting and processes and predictability associated with hazardous weather. So I'd also like to note that today's webinar is joint with the 8th International Verification Methods Workshop, which is a 2-week rolling workshop around the clock on forecast verification. And so I'd like to thank Barbara Casati and the workshop organizers of the verification workshop for allowing us to be joint. I'd also like to thank my co-host today, Martin Wegman from WMO. Without Martin's help and assistance, I think this webinar series would have been pretty impossible. So my name is Beth Ebert. I'm a senior scientist at the Bureau of Meteorology in Australia, where I'm currently leading an effort in the Bureau to uplift our verification processes and, importantly, our communication of verification results, both internally and externally to the people who use our forecasts. Before joining the High Impact Weather Project, I was a member of the Joint Verification Working Group, and I'm still connected to that through the WWRP. I'd now like to invite the other presenters to introduce themselves, so I'll just call them by name. So Barb, would you like to introduce yourself?
Hi everybody, I'm Barbara Brown. I'm a senior research associate at the National Center for Atmospheric Research, where I've worked for a large part of my career. And I'll be talking about some work we did on tropical cyclones, one of the major projects we had in our group, and looking at user-relevant forecast verification.
Thanks, Barb. Juli, would you like to introduce yourself, please?
Hello, everyone. My name is Julia Chasco. I'm the head of the Meteorology and Society Department of the National Meteorological Service of Argentina. I'm a member of the High Impact Weather Evaluation Task Team. I'm co-chairing the Socioeconomic Research Application Working Group of the WWRP program in WMO. My background is associated with social sciences. I'm a sociologist and MPP, and I work with disaster risk reduction initiatives in the context of weather and climate service provision.
Thanks, Juli. And Amanda, would you like to introduce yourself, please?
Hi, I'm Amanda Sims Anderson. I work at the National Center for Atmospheric Research in Colorado in the US. Worked with Barb for a number of years. I specialize in looking at verification of decision support systems and in road weather, and I'll be talking about the work we did to verify our coupled fire atmosphere model for the state of Colorado.
Thanks, Amanda. So the way that our webinar will work today, each of us give about a 15-minute talk. Each talk will be followed by questions from the audience. Please use the chat to put your questions in. If for some reason the chat doesn't work, you can email it, and hopefully one of us will be able to receive that and find your question. Apparently the Microsoft Teams hands function doesn't work for live events, so please do use the chat. And not just to pose questions, but if you would like to chat with each other or make observations, comments, the chat is a really great way to do that. And we'll be following the chat, in order to identify questions for the speakers. We have as much as 2 hours. And so if we do have some time after the 4 talks, which I expect we will, then we can go into some general discussion after that. So I will start off with an overview of the activities of the evaluation task team in high weather. Our activities are largely focused around the value chain of information, connecting observations all the way out to decisions in response to high impact weather. And so the sorts of questions that we are looking at, we are starting to, we develop appropriate verification methods for new kinds of forecasts. We also are quite keen to build users' trust by providing more user-focused information about the quality of the forecasts. A new thrust is using social media and non-standard data, particularly for high-impact weather, where you might be thinking about storms or floods. The typical meteorological measurements of temperature and humidity aren't really what you need. So there's a whole lot of new exciting data from social media and impacts and so on that we can use to evaluate these types of forecasts. We also have a big emphasis on social science to try and understand the decisions that users make in response to high impact weather. You can have the best model in the world, but if you don't do a good job with the warning and the communication and the understanding and the trust, then you may not get the response that you're wishing for. And then finally, we have a cross-cutting perspective as well, trying to apply methods and develop methods to look right across the whole warning chain, and linking the different communities that are working on different parts of the warnings, whether it's the meteorologists or the hazard community or the media or health. There's lots of communities that are involved in getting a warning made and acted on. So I'll go fairly quickly through the types of activities that we have been working on over the last couple of years and encourage you to maybe contact some of the people who are identified on the slides if you're interested in knowing some more. So starting with my first question about verifying new kinds of forecasts, there's been a lot of activity in the last 5 years or so applying spatial verification methods, which have been a very active area of research over the last decade or two. Now moving those to high-resolution ensemble forecasts, because that's the way, that's the frontier of weather modeling. And so the Mesovict project, which was joint with the verification working group, was looking at traditional variables like precipitation in wind, but now from high-resolution ensembles and in tricky terrain, the mountains of Europe. And this project is now finished. It was able to show that spatial verification methods that were developed for deterministic forecasts were largely able to be adapted to verify ensemble forecasts, which is excellent news. We also tested on the uncertainty of the observations by having a few different spatial analyses as the truth data set, and showed that the way you handle the truth or which choice of truth you use can have a large bearing on what your conclusions are. So that's something that we need to be quite careful about. We also have a member who's, Chiara, who's very involved in the UMetNet SRNWP EPS2, which is having a focus on now these high impact weather phenomena of thunderstorms and fog, where again, it's no longer state variables that are of highest interest. It's things like storm occurrence, extent, timing, intensity, things like that. And again, other kinds of measurements, such as lightning or visibility or impacts or crowdsourcing, are the kinds of data that you would use to assess how well those forecasts were performing. We've had some collaborative activity between Australia and the US on fire spread evaluation. And this is a new frontier of coupled modeling between the NWP and fire behavior models. And in fact, in Colorado, you'll hear from Amanda later the details of this work. But we've been able to use some of the simpler metrics that we use in meteorology, such as threat score or some of the spatial methods, to have a look at the fire areas that are predicted by the models and their sensitivity to the weather conditions, but also things like the fuel conditions, the ignition, location, and timing, and so on. Moving on to user-focused verification, we ran a challenge a couple of years ago for the best new user-oriented forecast verification metric. And we were very happy that we had 17 entries from 11 countries. The winner was an entry that was to do with measuring sea ice extent and the position of the sea ice edge. But it's a technique that can be adapted to anything which has an edge that you might want to verify. So that was pretty interesting. Other entries were rain-free window, thunderstorms at airports, and a weighted percent correct for seasonal forecasts. Barb will be talking in her talk today about user-driven verification of tropical cyclone predictions. And this was work that they did, the NCAR did with the National Hurricane Center to help them select which models they wanted to use in operations. And so the users in this case were operational forecasters. And they asked a number of questions, and Barb will say a bit more about it. But it wasn't just the standard, what was the error? It was comparing one model with another, and what did you want to know? Well, which model should I use? And that's a different question than we normally answer. So we'll hear more from Barb about that. I'd like to call your attention to the second verification challenge. So this is the successor to the first one, and the theme this time around is using non-traditional observations in verification. So we're looking for new metrics. It might not be a new score, but it might. But we're particularly encouraging people to have a look at the social media or third-party networks, things like that, that can be used to say something about not just high impact weather, but any kind of weather. The deadline for entries is 30th of April next year, so there's plenty of time to join if you're interested. The prize will be paid attendance and a keynote talk at the next International Verification Methods Workshop, which should be in about a year from now. And it's open to teams or individuals, and if you want to know more, there's a website here, or you can just Google International Verification Challenge and it should come up. Again, on the theme of non-standard data, one of the really exciting activities that Helen Titley and Joe Robbins have been doing at the Met Office for a number of years, but we're using it in high weather, is the Global Hazard Map, which is ensemble forecasts from a few global ensembles combined to look at extremes of weather and then the impacts that might be associated with those. So there are tropical cyclone forecasts in there, extreme heat and cold, extreme precipitation. And the evaluation that they've written up used a combination of approaches: traditional verification for rainfall, which is something that many of us are do every day, but they also pioneered some work in impact-based evaluation. And they collected a database of community impacts, which I understand was a lot of work, and then used that to verify polygons that were identified from the ensembles. And they've got very encouraging results. So I would encourage you to have a look at that work. I think it's pretty exciting. Another European project, again, so I should say that not all high weather projects originate with high weather. We're leveraging a huge amount of really great work that's happening out in the community. And so when people who are involved in those projects are part of the high weather project, then they bring that knowledge and that opportunity for others to participate in it. So the European Weather Observer is collecting crowdsourced observations of weather. This is part of the UMetNet activities, and Rainer Kaltenberger is our member in that. And that the idea is to try and standardize and collect that information to support the warning services right across Europe, and using standard displays and colors and things like that. On the topic of understanding user decisions, we have a very active couple of people in Switzerland who have been doing some fantastic work in this. And I particularly mentioned Philippe Weirich, who did his PhD as part of our high weather evaluation task team with his supervisor, Anna Skolobig. And they did a number of social science experiments to understand the way people respond to warnings, and they might have been sort of survey type experiments or serious game experiments, and they did also some real-time trials of how people actually respond to warnings. And so a lot of this work is written up. My last slide, which I won't talk to, has got a long list of references that you can follow if you'd like to learn more about this work. But one of the exciting things, I think, was some work that was suggesting that you can use these laboratory experiments in a valid way to understand the way people would respond in real time to warnings. Another very exciting development, which you'll hear about from Juli in her talk, is the development of the new early warning system in Argentina. I won't say a lot about it because Juli will give a whole talk about it, but during the life of high weather so far, it's gone from being a very traditional jargon text type warnings, which were maybe not that effective, to now graphical and very user-oriented, because it was co-developed with the emergency managers and members of the public and so on. So I understand it's launching next week or the week after next. Pretty exciting times. A few things, as I mentioned at the start, the warning value chain is kind of an underlying theme for the evaluation task team. And so it's very interesting for us to look across different parts of the value chain to see where value is being added. And so a project that Helen Titley is looking at for her PhD is how tropical cyclone heavy rainfall can then lead to flooding, and using the ensemble rainfall forecasts to drive ensemble flood forecasts, and then understanding how those ensemble flood forecasts can be used to create warnings that are more effective. There's also been in Europe a recent survey on impact-oriented warnings. So trying to not just say what the weather will be, but what the weather will do. This is a phrase we're hearing a lot as weather services move towards more impact-based forecasts and warnings. And the survey that was just written up and published this year indicated that most of the European countries are moving in that direction, and there's a lot of coordination going on to try and make sure that this is done in a way that is best practice right across the region. Socioeconomic benefits is one of these holy grail type topics. I think we all want to know what is the monetary value, the value in terms of lives saved or property protected from doing warnings. And this is something that we'll be working on a little bit more with some value chain work that I'll talk about in a minute. But I'd like to remind people about the SARA workshop, which is coming up next year. If you were listening to the communication task team, you would have heard Martin Gerber talk about this. But it's very much like the series of verification workshops, where it includes a tutorial session of a couple of days, followed by a scientific conference of a couple of days. And the intended audience would be practitioners, meteorologists. And so you can see the topics there. It's an interesting mix of mostly social science, a little bit of more physical science with things like impact modeling, but again, not just traditional weather science. It's really taking that weather science and making it real for the user community. And this is, I think, likely to be online, but I'm not absolutely sure about that. So I want to finish off talking about a brand new project of the high weather. It's one of the flagship projects of high weather, and it will be being led by our task team on evaluation. And using value chain approaches to evaluate the whole end-to-end warning chain, and it's joint with the SARA working group. And the aim of this project is to describe, measure, and ultimately improve the effectiveness of warnings by looking right across the whole chain for where improvements could be made, and focusing particularly on the links in between different communities. So I sort of glossed over in my earlier slides, but I wanted to mention the Green Mountains, which many of you will have seen if you've heard Brian Golding talk about the value chain. And he's one of the high weather co-chairs, of course, where the mountains indicate different capabilities or communities that are working in an area that's relevant to warning. And the bridges represent the flow of information, or maybe it's data, between the communities. And the bridges can be variously higher or lower depending on the effectiveness of that information flow backwards and forwards across that chain. So it's not just going down the chain, because the people who are receiving it also need to be communicating back up the chain about what they need, how they use it, and hopefully co-designing that information flow. And so this project is going to be collecting information on actual high impact weather events where warnings were made, maybe some even where warnings were made that the event didn't occur. And we're trying to collect as much data as we can from all of these different parts of the warning chain, so that we can evaluate it and try and understand what's working well, what's not working well, and develop some guidelines for best practice use of this value chain perspective. And we're really happy and delighted that Sarah has got a strong interest in this, and in fact they'll be doing a lot of the core work on value chains themselves. So how do you use a value chain to as a framework for organizing your data or understanding how information flows? And we're very hopeful that as part of this, we'll have some good methods on measuring the effectiveness of the value chain and guidelines for users onto how to do that and how to create their own case studies as well. In the long term, we'd very much like to link this with a WMO activity that's just getting going as well, called the Catalog of Hazardous Events, which will become an operational international system linking weather events with impact information from insurance and so on. So that is a big international activity from WMO focusing on part of the value chain, and we're going to be trying to enrich that, at least for some of the events, by looking more broadly and widely across the value chain. So this is my last slide for today. I'd like to encourage everyone online to consider joining some of these high weather activities, whether it's the challenge or participating in evaluating the global hazard map, the European Weather Observer, the SARA workshop next year, the value chain project. We'd be very happy to have as many people involved in that as who would like to be. And I'd also call your attention to the 3 high weather workshops coming up in the start of December. And if you're interested in joining those workshops and making a presentation, abstracts are being accepted for another week or so. You can send them to Martin Wigman or look at highweather.net for more information about the high weather workshops. I'll just flick to the last slide. I won't stay there, but the slides will be shared. If you want to follow up on any of those publications, then you can download the slides. So with that, I will stop sharing and see if there are any questions.
I don't see any questions at the moment, Beth.
Okay, thanks, Mark. We'll give it a couple of seconds since we know there's this delay.
Yes, maybe I could ask one while we're waiting.
All right.
If you're interested. No, I really like that sort of view of the value chain. It's really nice sort of to get the idea. How probabilistic is it? Does it all the way through? Are things probabilistic, or can people cope with that, or is it still deterministic?
I would say it depends. It depends on who your users are. Ultimately, decision is deterministic.
Yes,
usually.
that's the last one.
Yeah. And certainly the trend is to become more probabilistic. I think until we start looking right across internationally, we won't have a sense for how widespread that is. But I think for well-developed, sort of world-leading net services, probabilistic is where they're at right now, or desperately trying to get to. So we will be encouraging that, and a lot of our evaluation will be probabilistic as well. I should point out that evaluating impacts is kind of by nature probabilistic. There's so much uncertainty with the impacts that you kind of have to treat them in a probabilistic way.
Okay, thank you. We have a couple of questions come through now. I guess I should read these out, should I?
Yeah.
So one from Michael Foley. Responding to warnings. During COVID, we have seen validation of the impact of community restrictions based on analysis of Google or Apple phone location data. How much people are traveling? Has anyone looked at correlation between warnings and change of travel behavior as measured in this way?
Thanks, Michael, for that question. That's a good one. It's certainly being talked about, and I think there probably is some research on that. I'm not sure if it's being used in operations anywhere yet, but I believe there is some research on that, and that's certainly travel patterns. Definitely one of these things that we'd like to look at. I suppose getting hold of that data is not always easy, but it's something that I think universities are starting to work on for sure.
Okay, we have another one from Rini Sieber, is it, from McGill? Curious if anyone is working on ontologies of these high weather events. In our project, we compared old and new snowstorms and found that we first had to define a storm that covered the full temporal extent of the storm. Not necessarily easy to tell when the storm starts, but sub-daily observational data. I'd argue that the need for ontologies is even more important when using social media data in unsupervised classification, because you shouldn't rely on the unstructured content to determine what constitutes an event. I'm sorry, I was struggling to keep up with that question myself. I
think I get the gist of it.
Gist,
and
yes. Okay.
I don't know to what extent those things do exist already, or how much standardization will be possible. Certainly for our value chain project, we're going to be trying to organize data in ways that will enable ontologies to be done with them by collecting information about start-stop location, what the forecasts and warnings were, and so on. But I would agree that that's something that we'll need to do in order to make sense of things. And I don't know whether there are within WMO, within the DRR part of WMO, groups that are working on specifically that. I know that there's a new publication out this year that is classifying hazardous events and defining them, and that might be a first step in getting an ontology that everyone can use and agree on.
Okay, we have one more from Robert Rogers. The value chain seems to be the idea linking together all of these webinars. There are different locations along the chain. Would you agree?
Yes, absolutely. And we've used that in our high weather workshop in Beijing a couple of years ago as well. The evaluation test team is interesting because we probably are a little bit unique in going the whole length of it. But yes, that's been a very useful construct. I should mention too that while we've been presenting it as this linear flow, that in fact it's actually a network. It's much more complicated than that. And so the value chain project will probably continue to use a linear framework, but recognizing that a lot of links are going, right across to other areas and many different players and so on. I would refer you to a paper by Rebecca Morse in BAMS a couple of years ago that really describes how complicated it is. Yeah. And
a question from Brian Golding, if we've got time. So this is, I think it was responding to Michael before. He says there was an interesting study using this sort of data of how people responded to Superstorm Sandy in New York, distinguishing those who evacuated from those who stayed and what each group were putting in their social media posts.
Yeah, that's a really good example. And that's probably a great case to include in our database for learning, have what works and what's not working so well.
Yeah, very interesting. That's it from the Q&A here.
Oh, thank you very much, Mark, for that. I think we'll go on then to our next speaker.